The Carnaby's black cockatoo is a bird native to southwest Australia. A birdwatcher is interested in estimating the proportion P of birds living in a Western Australian national park that are Carnaby's black cockatoos. The birdwatcher visited a national park one morning and, standing at their favourite birdwatching location, observed 200 birds flying past. 76 of those birds were Carnaby's black cockatoos. On the basis of the sample, determine a point estimate for P. So P is going to be 76 divided by 200. And that is 0.38. On the basis of the sample, determine a 95% confidence interval for P. Well, there's different ways that you can do this. 95%, the first thing you need to do is find the Z95 figure. We'll look at that again in a minute, which is about 1.96. And so you can start with the 0.38 point estimate and take away 1.96 times the standard deviation, which for P equals 0.38 would be 0.38, multiplied by 1, take away 0.38, divided by n, which was the number of birds we saw, which was 200, and then 0.38 plus 1.96 times the standard deviation, again 0.38, 1 take away 0.38, divided by 200. Calculating that gives us 0.3127, 0.4473. But note it's 2 marks. We don't really need to show all of that working. We could have done that just using our e-activities. So if we go to e-activities and we want to be in methods 3, 4, and so first thing, Z-score for confidence interval, go in there, and we wanted a 95% confidence interval, so we put it 0.95, and we get the Z-score figure that we used as 1.96. You can use more of it if you wish. And then we have confidence interval for proportion in here, and we don't actually need that Z-score figure, but I would write it down because you might get a mark for that, just in case you get this wrong. And our proportion was that we saw 76 out of 200. And we'll leave that at 0.95. We wanted a 95% confidence interval. And we'll just hit execute there. I was in standard. Let's go back to the top and do it in decimal. And you can see 0.3127, 0.4473. So we could just do it using the e-activities. So for the next part, what is the minimum number of birds that would need to be sampled to ensure that the margin of error of the 95% confidence interval for P is at most 0.02? Margin of error max would mean taking P hat as 0.5. That will give us the maximum margin of error. Now I have here a Z-score for CI, and then just above that, sample N for CI. I think that's the one we want. Let's just go in there. Yep, that's the correct formula. And notice that the Z-score from before is in here, so we don't have to worry about that. Now, you can use that to write down 0.02 is equal to 1.96, and the standard deviation now would be 0.5, 1 take away 0.5 divided by n, and we'd be solving for n. But we can just use this. So we don't know the n, we're trying to find that. And the p, we'll make that into 0.5. And the margin of error, we want to be 0.02. And then just solve. And it's about 2,401. So this is a situation where you'd always round up, but clearly with this being a 0.9, you're going to round it up. Finally, we want to identify and explain two sources of bias in the birdwatcher's sampling method. And the two that I've come up with, and you'd need to expand on them a little bit for 4 marks, is that it's a single location. And you know that if you're in just one location, you're unlikely to get a really representative sample. You need to stand in different locations. And a single time. Different birds have different habits. They might be out at different times of the day and so on. So you need to expand on that. You get 1 mark each for those, but you need to expand on it in order to get the full 4 marks.